Those houses that the electrons live in, they're called valencies. I don't need you to know that, but when they share electrons, when the houses share electrons, then that's called a covalent bond, like a co-ed dorm. Covalent bond means the electrons are being shared. It's very difficult to separate covalent bonds, and so when we read in pharmacology about something that's caused a covalent bond on a receptor, then we know that that's essentially irreversible, and that's why I talk about this stuff. Does anybody have any idea what I'm talking about? At least somebody does. Okay, we've talked about hydrogen, and it can make one covalent bond, and hopefully I've kind of explained how that happens. Hydrogen makes one covalent bond. All right, let's talk about oxygen. Oxygen wants to make two covalent bonds because oxygen has two spare electrons to share and room for the two extra electrons. So oxygen can make two covalent bonds, and in the case of oxygen gas, those each bond is made with the other oxygen. This is called double bonding. So here is an oxygen atom. O is the abbreviation for an oxygen atom. Here, maybe that'll help. All right. Here's an oxygen atom. And here's an oxygen atom, and each atom can make two bonds, and those bonds are described by these little lines. That's not an equal sign. All right, those are two covalent bonds. That's called double bonding. So every time you see an oxygen, it's going to make two covalent bonds for the most part. There's some confusing things, but it still makes two covalent bonds. Well, here's neon, the same neon in neon lights. It's inert. It doesn't react with anything. You pass electricity through it, it'll light up. Just like a neon sign, that's what's in neon signs is neon. Neon's inert, and it has 5 happy houses of electrons. The 2 center houses, just like hydrogen did, and then as the number of protons build, how it configures the arrangement of the electrons. Those are called the orbital shells. They have all sorts of interesting names like S and P and stuff like that. So here, neon has 5 houses. There's 1 house in the center and 4 houses around the side. All right. And all the electrons are in pairs, so they're all happy. They're not going anywhere. That's why neon's not going to react with anything. All right? But oxygen, it has 2 empty houses. All right? So there's an empty house with an unhappy electron, and there's an empty house with a poor, lonely electron. And what does the oxygen? What are these 2 oxygen atoms going to do? Well, they're going to combine and share their houses in a definite arrangement. So now we have an oxygen molecule. All right, and these are the words that get thrown around in pharmacology class while people wonder what it is that guy's talking about. Right? So there's my oxygen molecule. Oxygen is present in our atmosphere. Air is made up of only 21% oxygen. All right, the stuff we breathe is not 100% oxygen. We'd blow up if that was the case. All right, oxygen gas is present in the air at 21%. And to confuse everyone, we can use abbreviations that make no sense to anyone except respiratory therapists and a few other people. A fraction is always a number between 0 and 1. A different type of fraction when it's not drawn with a line. Fraction of inspired O2 equals 0.21. That leading 0 is very important, be sure. So this is the way to write it with words. This is the way to write it with Pig Latin, okay? FiO2 is equal to 0.21 is the same thing as air is 21% oxygen, okay? People are going to think you know this stuff. That's why we talk about it, all right? All right, so you take oxygen gas and you put it together with hydrogen gas. What happens? Nothing, all right? But what if you add some activation energy? What if you inject just a slight amount of energy into it, like with a spark or a flame? Then what happens? The main shuttle engines used to combine liquid hydrogen, liquid oxygen, and cause them to combine, releasing energy called fire, all right? And the byproduct of that was water. Somebody's like, well, where's the carbon dioxide? Well, there's no carbon in the reaction. All right? So when we mix hydrogen gas and oxygen gas and light them, the byproduct is water. Okay? Same thing goes on inside of your body, just much slower. All right? So burning hydrogen gas and oxygen gas results in water, and everyone misses this on the quiz because you guys don't read carefully. So I like to use lots of trick questions to teach you how to read and take tests. So when you take real tests written by people who actually know how to write test questions, you'll be very well prepared. Okay? So don't miss this. Don't get burned by this question on the quiz. I'll post the quiz later. I'll send you guys an announcement. All right? Here's the official reaction, balanced equation, for those of you who need balanced equations in your life. Two hydrogen molecules combined with one oxygen molecule will result in a huge thermodynamic exothermic reaction, fire, and two water molecules. Right? When your body uses hydrogen and oxygen as energy, water is the end product of that as well. But your body does things in a very complicated manner so that you don't explode, and people don't explode, I promise, regardless of what they tell you on television. Let's talk more about water. Water molecules are not flat. This is very important. Water molecules are not flat. The oxygen is covalently bonded at angles with the hydrogen. That's why we draw it this way. Okay, so this is H2O. Ever heard of H2O? This is water. Two hydrogens, one oxygen configured in a molecule, water. All right? So this is a molecule of H2O. H2O. Even though the oxygen and the hydrogen share an electron, remember there's two happy sets of electrons up here. I think I have a picture of that. All right, well, when we take the H2O, remember that oxygen had two happy houses of electrons that don't share. And so that makes this end with the more electrons, this makes this side more negative. And because of these little protons that ended up here, this makes this end more positive. Okay? But still, water is neutrally charged, but it has a negative side and a positive side. So that makes water polar. Makes water a polar solvent, and this is why. Because one side's negative because of the happy electrons, and the other side is more positive because those hydrogens have positively charged protons in the center of them. Trust me. All right, water is polar. The water molecule is polar. I think I mentioned that. Well, because water is polar, it's going to attract certain things like charged ions, something with extra more protons than electrons is going to be positively charged. Something with more electrons than protons is going to be negatively charged. And something balanced is going to be neutrally charged. So the water is a great place to dissolve things that are polar, something slightly more negative on one side, slightly more positive on the other side, and charged ions, like positively charged things, negatively charged things. But because water is polar, it's going to push away things like hydrocarbons, lipids, fats, and oils. So water and oil don't mix. That's where that comes from. Water repels oil. If you don't believe me, go to the grocery store, get a bottle of salad dressing that has oil and water, and mix it up until you have an emulsion, and then put it back on the shelf when the manager's watching. All right, so water is polar. I've explained that. Well, something else that goes on is something called hydrogen bonding. Notice that this little more positively charged side of the water molecule is going to be strongly attracted to the more negatively side of this water molecule right here. And so they draw little dotted lines. Okay, and those dotted lines are called hydrogen bonds. All right? And if you look at the water molecule forming its hydrogen bonds, you can see the beginning of a snowflake. We don't really have these here except certain winter days up on top of the mountain. All right? Google the Hindenburg. It was a blimp. It was filled with hydrogen gas to make it float, and one day a little spark caused it to explode and burn in about 1 minute and 20 seconds. Okay? So hydrogen and oxygen are combined together to release enormous amounts of energy. This is done instantaneously. We don't want our bodies to do that. We want our bodies to burn in a very efficient manner. So biologic systems must control that burn in a very slow, very efficient, and stable manner, because biologic systems are the masters of efficient, renewable energy use. They talk